Okay, this is the P3 paper from October 2021. It's question number 8, and this is mainly a trig functions question. We've got some inverse trig there that we're going to need to sketch. We need to be able to differentiate trigonometry, and when we do, we're going to need to use the trig identities to get it in the right format there. And at the end, there's a finding the equation of a tangent, so all the differentiation work that goes with that. Let's start with part A then. Part A says, can we sketch fx equals arc sine a half x between these values here? You can see it's only one mark because this absolutely is just a basic have you gone away and learnt what these graphs look like. So if I draw out a set of axes, you should automatically know without any extra work, just go and learn these by rote, what arc sine x looks like. Arc sine x looks like that. We're only interested between pi over 2 and minus pi over 2, and at those values we have an asymptote at 1 and an asymptote of -1. So this is y equals arc sine x. And there's no explanation to that. You just got to go away and learn that's what arc sine x looks like. All they've done is they've said, can we have arc sine a half x? So when we do f ax as a transformation, hopefully you remember this is a stretch scale factor 1 over a, parallel to the x-axis. And so stretch of 1 over a is going to be a stretch of 1 over a half. So it's actually going to be scale factor 2. And what that means, without this is what I've written it all out already, is that basically all that's going to happen is that these two limits are going to be 2 and -2. In effect, it's been stretched in that direction, but if I leave that as my answer now, the examiner doesn't know that I didn't do all the work necessary for that. So only one mark, don't worry too much about that one, part A, but do go away and learn the sketches of the inverse trig functions. Part B then, what we're now saying is that x is equal to 2 sine y, and can we show that dy by dx is going to be equal to this thing? Okay, again, with this is really a matter of experience and doing some of these questions. I know what I've got to do here, and I know it's going to take me quite a while to get to the final answer. First things first is to say I can't find dy by dx, but I can find dx by dy, because that's simple. Dx by dy, differential of sine is cos, so it's just 2 cos y. So it means, yeah, I can get dy by dx. Dy by dx is 1 over that, so it's going to be 1 over 2 cos y. But then the answer that they want, I'm not going to go back to it, but the answer that they want involves x's and not y's here. So what we need to do is to get x up here from cos y down there. And it's not anything new, it's not anything that I don't know what to do. I'm going to be using the fact that sine squared theta plus cos squared theta equals 1. Or more importantly, now I don't do the rerouting of all this. What I actually do is I just know then that cos theta, if I rearranged all of that, is the square root of 1 minus sine squared theta. And I've learnt that alongside the identity sine squared plus cos squared equals 1. It's interchangeable with having sine there and cos there, or as we've got it here. So now what I can do is I can say from the top part, x over 2 is equal to sine y. So if I've got that dy by dx is 1 over 2 cos y, it's 1 over 2, well, cos y, using that information now, is the square root of 1 minus sine squared y, and now substituting that in, dy by dx is equal to 1 over 2 square root of 1 minus x over 2 all squared. Now that would be great if they let me just leave it like that, but if we actually go back and have a look, we've got to have it in the form 1 over root a minus x squared. So it just means tidying up this fraction here. So I've got dy by dx is equal to 1 over 2 root, and this is 1 minus x squared over 4 now. And just quickly, I'll just show you what I'm doing, but actually I won't do any method in terms of my answer here. If I've got that, by changing that into that fraction there, I can just do the cross multiplying bit of fractions that I do. So I'm actually going to get that 1 minus x squared over 4 is the same as, everything else stays the same, 1 over 2 root. But now instead of having 1 minus x squared over 4, I'm going to have 4 minus x squared all over 4 there. So we're nearly there. We can just say this is 1 over 2. Now the root 4 minus x squared comes out, and this 4 here, the square root of 4 is going to be 2. So that's going to give me that like that. Don't know that I necessarily need that step in, but to give me my final answer then of 1 over, and I just have root 4 minus x squared. And I don't need that bit there. That was just for me doing my working out there. Now I do have that in the format that I wanted. A is going to be equal to 4. So we knew we were going to have something like that to get through. You just need to be really careful with your algebra as we're going through and doing it. But good practice of our trig identities and also some algebra. Right, the last part then. What does the last part say? It says, can we find the equation of the tangent to C at P? And don't forget at the end to write our answer in the form y equals mx plus c. So if I'm wanting the equation of a tangent, let's get started with it. If I'm wanting the equation of a tangent, equation tangent, I always write it down that it's y minus y1 equals m, x minus x1. M is going to be the gradient. X1 and Y1 are going to be points that we've been given, and in the question we're told that the Y coordinate Y1 is equal to pi over 4. So now for this, what we've got to do is we've got to work out Y1, which we've got, M and X1, and just tell me what you're doing as you're actually finding them. So I'm going to start off here by saying y1 is equal to pi over 4, so I've got that straight away. And if I want to work out x1, it's just working out what x is going to be. It was 2 sine y, wasn't it? So it's 2 sine pi over 4. Do that on the calculator. That works out to be x1 working out to be root 2. And if I now want to work out m is going to be dy by dx. So dy by dx we had was 1 over the square root of 4 minus x squared. I'm going to say for m here. Let's make it clear what I'm doing. So dy by dx is equal to that. And that's going to again be at the point where x1 equals root 2 now. So that's going to be 1 over the square root of 4 minus, I'm going to put root 2 squared here. I wouldn't normally do that, but it's just making it clear what I'm doing. That's just 2, isn't it? So it's 1 over root 2, and we don't leave it as 1 over root 2. We write that as root 2 over 2. So now, if we go back to this one, I'm actually just going to copy that out again now and say for my equation of a tangent, what's x1, what's y1, and what's m. I always do this because it's a good idea. You don't have to, but it just makes it clear to the examiner what values I'm using. So x1 is root 2, y1 is pi over 4, and m is root 2 over 2. And also I think I'm less likely to, hopefully, less likely to make a mistake now subbing that all in if I've already put those values there. So we've got y minus pi over 4 is equal to root 2 over 2 x minus root 2. Right, so if we're doing that, let's get rid of this 2 on the bottom. Well, no, if I want this in the form y equals mx plus c, so I've just remembered what I was going to do. Otherwise, I'd multiply that out and tidy it all up. But because they want it in the format y equals mx plus c, probably makes sense just to say, so y minus pi over 4 is going to be root 2 x over 2 minus, and if I'm doing root 2 over 2 times root 2, that gives me 2 over 2, that gives me 1 there. So now y is equal to root 2 over 2x minus 1 plus pi over 4 there. So what I've got is I've got it in the format I wanted. Here's my m and here's my c there. So do they ask me to actually state what they are? Yeah, m and c are constants to be found, so I've got that in the right format there. I don't need to do any extra work with that. Okay, complicated question, long, involved, but hopefully that all makes sense to you.